And thank you very much for coming here today. My name is Valdemar. It's like Voldemort, only I'm nicer. I'm nicer and I have a nose, so that's a big advantage. It's a pleasure to be here with you today. When I was first invited to speak here at PyCon, at first I was really excited, but then it got serious. When I looked at all the wonderful topics other speakers proposed, like Jarka, who works in CERN, or Andrei's space project, I thought, wow, that's really cool. And then here I am teaching first years the if statement. And I thought, okay, remember your training. You know how to start a presentation, introduce yourself, ask a question, and tell a story. Okay, so let's go. That's me when I was 5. Now I do my master's in computer security, and I also teach Python programming. I won an Academic Senate Award for the best student teacher, Dean's Award for an excellent academic performance, and Dean's Award for my thesis, but that was written in Java, so forget about that. I like creating mathematical videos, playing guitar, boxing, and traveling. Now, let me ask you a question. Do you remember how did you start programming? Maybe your first day when you wrote Hello World? Who of you remembers? Okay, so almost everyone. It's great. Let me tell you how I started. I was 15, and my whole computer science class was rewriting Pascal programs from the whiteboard to the computer. So that's me. And the worst thing was that the teacher didn't understand how the programs actually worked. This sucks, I thought. I want to learn programming, but it won't happen here. Fortunately, our high school opened an after-school programmers club, and it changed my life. The teacher that was there, who led the club, gave us interesting and challenging tasks and explained everything thoroughly and helped us even with tiniest details if we needed. And the club really motivated me to pursue my interest in computer science and study at university and work in IT, which is great. And I also made a few friends there, which made the whole experience a lot more enjoyable. And I thought that the teacher helped me so much. And a few years later, I decided that I want to pay something back to society, to do for others something that the teacher there did for me. So I started teaching Python programming at my university. And if you follow the structure, now I'll be moving to here. I'll tell you a little bit about what we do in our programming course. The course is called Introduction to Programming, and it's a beginner's course for people who have no prior experience with programming, so it's usually taken by first years. It's also open for general public for a fee, and in the course we obviously learn Python, which is the most popular language statistically, even in the best tech universities around the world like Carnegie Mellon or MIT or Caltech. And I'll show you a few of the projects that the students are assigned to give you a brief idea how they progress from zero, that is knowing absolutely nothing, to being a hero, that is being able to create their own simple pieces of software. So programming it might be scary to start, if you never programmed before. It seems like some metrics coding stuff that's really strange to students. So we start easy on them with turtle graphics. Yeah, so students learn their first Python commands by drawing on the screen, and I think it's a great introduction to programming. And then they can work on building their programming arsenal, which is, if statements, loops, functions. And for me, it's like when you study a natural language, like learning grammar and vocabulary. So you can't really create stuff unless you have some basic vocabulary. So in programming, as you might know, this is often done by programming some mathematical computations, like recognizing which numbers are prime. I'm a mathematician, so this is left as an exercise for the readers. And yeah, this is fun for some students, but it might be not fun for others. So they also program, for example, a board game where you move a figure around the game plan based on throwing programmed dice. Now, when you learn something new, you always make mistakes. Mistakes are inevitable. And they are also really useful when learning something new. Because when you are a teacher, seeing a student make a mistake gives you a better idea about how the student understands programming and where might be his or her weak spots. So let me show you 3 examples of mistakes that my students recently made. And as a teacher, you have to be somehow like Sherlock Holmes. You have to identify what's the cause behind doing these mistakes. So for example, some students think that it's a good idea to endlessly indent. And this mistake has a really simple cause. You just need to teach them some good programming practices and tell them, okay, this is not a good idea to do. And some more complicated mistakes, it's something when they write data poetry, it's a code that doesn't make any sense. And you see the syntax is wrong and you don't really know what the student was trying to express. So I asked him, okay, so what was the reason behind writing this code? What did you mean by that? He said, no idea. So this shows you that there are some serious gaps in the student's understanding, and you need to work with him or her individually to fix that. And this is sometimes really hard. And then, as a teacher, you take some things for granted, things you know, like, okay, this is easy, everyone has to know that. No, you can't take anything for granted. Even the very, very basic things that are totally obvious to you might not be obvious to someone. And you can even rely that students know basic stuff like propositional logic. So some students write if statements, which makes me question the foundation of mathematics, like this one. So you can't assume everything and really be prepared for reacting to any mistakes and correcting the students. So this was a brief detour. I'll now return back to the what for a while. The students then program ciphers, programs that work with text and create secret messages like this simple Caesar cipher that's on the slide. It just works by shifting each letter in some position. And they also do text analysis. As you probably know that it's quite useful for linguists to check the text, which letters are the most common, and so on. And it's quite fun for them, because they can analyze their own text and look at the patterns. And then important programming concepts like binary search, recursion, and objects are learned by programming games, because it's the most engaging way for everyone, I would say. So for example, when students are introduced object-oriented programming, they program a simple text version of Mortal Kombat game. So yeah, that's really cool. It's a favorite game of students. Yeah, so at the end, they work with text files and images. And by the end of the semester, the course takes 12 or 13 weeks. They are hopefully able to solve really practical problems working with images or files. So you saw their venture from zero to hero. And what's really important is that all these great stuff like ciphers and games, images, is attainable in around 100 hours of practice. Some students need less, some students need a lot more, but if they work, it can be done, and then they gain a solid foundation to explore Python on their own and to be able to learn other libraries and other stuff from a website and so on. When they have strong basics, they can learn anything that's interesting for them later. Okay, before I move to how, one example of mistakes that not only students make mistakes, but also teachers make mistakes. So it happened once that a student, let's call him John, he submitted a code like this with really bad variable names like A, B, C, D, I, X. I said, come on, John, give those variables nicer names, just something better. And I returned a minute later to see that all the variable names changed to John 1, John 2, John 3. So when I said nicer names, he obviously thought that his name is the nicest, but yeah, so as a teacher, you really have to focus on every single word that you say because the students might interpret it differently than how you mean it. Okay, I'll show you what the students learn, like they program games and ciphers and so on, but the key is how to learn stuff. And I'll share with you some experience with how I do it. There are many different methods for effective teaching. I'll just show you what I use. Okay, many students, as I mentioned, start coding without thinking about the problem. So they just, yeah, so here's the task, okay, and they just start bashing into the keyboard without thinking about it. So I really encourage them, when you have the big picture about the task, just think about it, break it to parts, focus on one part, program that, and then add maybe more fancy stuff. And this seems like quite a simple idea to me, but this is so hard for many students to learn, and then they struggle unnecessarily. So really some students need individual approach and help them with each task, tell them how to break it down, program first this, and then continue with this, and so on. This analytic approach is really difficult for some. Since the classes have the benefit that there are other students, I employ pair programming often. So if there are two students on approximately the same level, they sit behind one computer, and one person is doing the programming and explains the code that's being written, and the other person checks on the code and gives some suggestions. And for the person who codes, this teaches the valuable skill of explaining the code to someone else. And for this person, it teaches him or her sort of doing a code review of others' code. So it's really useful. And if the class is unbalanced, like some students are really advanced and some are total beginners, because that happens sometimes, peer tutoring works very well. So you take the really advanced student who then works as a mentor and guides the beginner. So the beginner sits behind the desk and does some programming, and the mentor sits next to him or her and gives advice. And I always ask students for feedback, how they like what they do in classes, and they say that they learn more this way when they are being tutored by a peer. It's more interesting to them, and it's a lot more fun. And statistically, from my experience, the best groups are male-female. So they work really well together. And two females are also great. I think that women are usually, from my experience, more cooperative and helpful. Sometimes if you have two guys, they sometimes don't want to work together because of their ego. But so how to encourage people who don't want to work together and you think it might be really useful for them? Well, I have to stress that I learn the names of all my students immediately, and they learn their names among each other. So our whole class knows at least the first name of all the students who are in there, and they know my name, and it feels more personal. So then when you're asked to work in a pair, you'd much rather work with someone you at least know the name and some basic stuff about the person, compared to when that's just some completely anonymous guy which is sharing the class with you. So learning the names gives really a good working atmosphere, creates a group feeling. That's really great. To keep the classes interesting, I present a lot of practical problems. Like you've seen, it's even better if they are varying. So you've seen there are ciphers and games and image processing and so on. And yeah, so coding has to be practiced, like playing an instrument or sports or any other skill. And by practical examples, when you code something, this sparks the biggest interest. And the students enjoy the feeling of creating something, and even more if they can share it afterwards with friends. If they create a game, they can put on their website, yeah, I did this in my class. That gives the greatest motivation. And for many programmers I know, and I think this is true about, I would say, all of you too, this joy of creating something is the internal motivation for what they do. Okay, I try to keep my students active during most of the lesson. So when they learn sorting algorithms, for example, like select sort and quicksort and so on, they receive cards with numbers, and they play as variables, and they have to sort it themselves in the classroom using this algorithm they are about to program. And this makes them really think about what they do, and then the results are much better. They program it faster and with less errors. And I also employ contests, which are rewarded by sweets or bonus points, and quizzes, and Python-related jokes, which can be understood only if you are prepared for the lesson. And so I try to vary the lesson as much as I can. I receive very positive feedback from the students, which really motivates me to work more. And I think teaching is really challenging sometimes. But when you see a student succeed, it's really a beautiful feeling. So that's really great. That's what I like about it. And coming to an end, well, you are all experts in programming. You do different things. Some of you might program websites, some of you do image processing or whatever else. But you are all experts at what you do. And you saw some ideas of how you can teach Python to others. I hope at least some of it inspire you. So I encourage you to share your knowledge. Write blog posts about what you do, and go to conferences like this and speak about what you are good at, and maybe join, these groups like PyLadies or some people who organize Python teaching for others. Join them and help them. It's really great. So thank you very much.
Thanks, that was excellent. I loved your hand-drawn slides.
Thank you.
I think that's the first time in my life that I've actually seen that. I have one question before we answer the other questions. What's the percentage of women in your courses?
A total in our faculty is 12% of all computer science students are women. And in my classes, there are usually 20 people, and around 5 of them, I would say, are women, so 25%.
Right, so it's not always possible to make the pairs male-female?
No.
Mm-hmm. Yeah.
But some students don't even want to be in pairs, so if they really, really don't want to, I don't force anyone.
Sure. So we have some questions. You switched to Python 3 this semester. How's it going?
Yeah, it's going really great. I think some of the stuff is more natural, like the division and the basic stuff works nicer in Python 3. So I think students have no problem with that.
Somebody's saying that it was awesome talk, and they will use some tips.
Thank you.
Yeah, look at that, great talk. Do you have any experience with improving level of programming teaching on high school?
Actually, I'm negotiating with one company which does workshop on high schools to join them. But so far, no, I haven't taught in high school. But I will if I get the option.
Mm-hmm. If there are free classes, don't you have a problem with students gradually abandoning the course? It's not the case, right? It's not a...
Yeah, so always, each year, it's my 3rd year now, and I taught several groups, and always it happened that one student doesn't finish the course. But there are usually other problems. Like, for example, the student fails at the mathematics course and is kicked out of the school, so then he won't finish the school.
Uh-huh. Do you have experience in online teaching? Any advice here in terms of engaging in collaboration?
Yes, I have. I have a channel, Teach Yourself Mathematics, where I do record these mathematical videos. I'm inspired by Khan Academy. So, and it's a topic for a long discussion. Well, just to answer a question briefly, if you want, then come afterwards and we can talk. Definitely make the videos short, less than 10 minutes, definitely, because some students can't keep their attention for too long. And present a lot of practical examples. Like if you teach mathematics like I do, then connect it to something that is used in the real world.
Mm-hmm. Where do you study, or where did you study?
Faculty of Informatics, Masaryk University.
So, yeah.
Here in Brno.
How many students in your class? So you said usually 20?
Yes. It's better if there are less of them, because you can work individually with. If there are 10 of them, then you have twice the time for each student, so that's better.
Sure. And how many hours does your course take weekly?
It's 2 hours for 13 weeks. But you really need to, if you are an absolute beginner, to work home too. So we give homework and bonus assignments and so on.
Did you think about open sourcing the course or your teacher notes? Well, you know, these talks will be recorded or are recorded, and then you will be able to see the slides and the presentation. Okay, so the course is supervised by some professors in our university, so someone who has a higher rank in the university hierarchy by me. So I don't think I can open source everything. I share my materials for the whole faculty. So even for the whole faculty. So even if you don't attend the course or my group, you can access the materials and the exercises and do them. But I don't think that right now the full source can be shared as it is, because it's university property, or I don't know how to say it. Yeah, sure. Are you planning any new projects in your YouTube channel? So you've got a fan club, actually. I want to, but I do videos for a private company. So now when I record the new mathematical videos, I don't upload it to YouTube, and I sell it to a company which uses it to teach mathematics in Slovakia and Czech Republic in elementary school. So yeah, I would love to share some more videos, but when I have time to create something, it almost always goes to the company these days. But I would like to start maybe my own business, so later we'll see, with education and with videos. Excellent. Do we have any questions? Any more questions here?
Thank you. Can you hear me? Okay, perfect.
Yes.
How do you solve it with theory? I mean, how do you tell them theory? Do you create your own materials?
Okay, the ideal way how it should go is that there are lectures before I have only exercises like seminars. They should go to the lecture to learn the theory there, but it doesn't happen. So I pick the theory that is needed for that particular day, and sort of pick the most important things, like syntax of the commands and so on, and I present it in the first 10 minutes. So it has to take very short time, and then they can start programming immediately.
And do they read something on their own, or are they encouraged?
I give them, so my dream is that the classes would work like that. There are no lectures, but there is reading assigned. So you do your reading at home, and you come to the lecture prepared, and you can do the practical stuff and exercise immediately. So no lectures needed. So that's my dream, but probably impossible. But I try to encourage students to do this. So I give optional reading, and if you give something optional, then if you have a really motivated group, then around a third of the group does it. If you have less motivated group, then 10–20%. So some students do it.
Thank you.
Thank you.
Yeah. How important is for you to teach them to navigate documentation?
Okay, that's a really important skill, and we say that.
How do you do it?
Okay, there are several approaches for this semester. We leave this topic to somewhere to the end of the course, and there are several approaches we want to try. I will try to give them a library that has few functions and is well documented, so they won't be overloaded by stuff. And they will have to create a simple example of using the functions without me teaching them what the functions do, but they have to read the documentation. But there are many other options. You can, if they are more advanced, you can ask them to set up, like do pip install and install library, set up something. Did I answer your question?
Yeah, yeah. And do you use like version control, something during the courses?
That's also a really important skill, but we have most of the class are absolute beginners who are happy if they can write something simple. And the version control is mentioned on the lectures. There's a really important and practical skill if you are going to be a software developer, but we don't exercise it in class. At least not in this one, in more advanced, yes.
Anyone else? If not, oh.
I would like to ask more about online teaching, if you don't mind. I mean, have you any experience in like live online education, not pre-recorded, but
yes.
live with not one-on-one, but like with a class?
Very few, but I do via like Google Hangouts or Skype or something like that, where you can share your screen and you write on the screen some math problems and explain to the mic.
Yeah, but you mentioned a lot of good exercises which involve like people presenting in the room. That's why I'm asking about some activities online, because there are some specifics, you know.
Okay, so do basically the same content but online? I don't have any experience with that, and I think that some of it wouldn't be possible, because it's some of it that is possible only if you have people in a room and you can interact with them directly. So online teaching for me has some limitations. Okay, so it has some limitations, I would say. Did I answer your question? Not really.
Okay, but thank you. I understand what kind of experience you have and what's your approach.
Okay, so if I didn't answer really, you can come afterwards and we can talk.
I didn't catch which question was the new one, but somebody says that you should cooperate with PyLadies, Bruno, and Pivo meetups. So yeah, you should do that.
Okay, yeah,
right.
let's do it. Give me a contact email or something. And
So thank you for this really great talk.
thank you very much.